Hey, in this video you're going to have a look at how you can implement a token counting method to check that you're never going to go over the context window of any of your models. Context window is important because you've only got a certain amount of tokens that you can use with the input and output tokens in each individual LLM request you can make. Let's have a look at a simpler implementation about how we can count our token size whilst interacting with the Open API, and then also make sure that we go under that token size for subsequent LLM requests. To start with, we're just going to import a couple of different packages. We're going to be using the OpenAI client, and we've also imported another package that OpenAI recommends, which is called Tenacity, which is a really great package for rate limiting your LLM requests. And it has some nice features like stopping after a certain number of attempts and waiting for a random exponential, which can be useful. So it's got some retry logic built in. So we'll see how to use that as well. So we initialize that, and then we also initialize the client. After we've initialized the client, then what we're going to do is we've entered in your API key, and then you've got these article headings that we're going to use to write a Financial Times website article. So now that we've had a look at those headings, we can now scroll back down and have a look. We've got a retry function that basically does a ChatGPT request, but we can wrap it in some retry logic. And after it would fail, after 6 attempts, if it failed on the 6th attempt, and it also has this thing where it can wait a random exponential amount of time between 1 to 60 seconds. So wrapping some of your LLM requests and rate limits can be quite nice if you're doing a lot of throughput. Now, this is a function which passes the chat history, which returns a Python dictionary. And if it's the user prompt, it will return the role, the user, and the content. Else it will return the role, assistant, content, and then whatever came back through the response. We then have a very large function here, which pretty much its main purpose is to count the number of tokens within the messages. So you can see here you've got this encoding, and we're using this package tick token, and we can take in a specific model and we'll get an encoding for that. And if there is a problem, we'll just default to using the CL100K base encoding. Now, if the model is in this one, we'll add 3 tokens per message and 1 token per name. But you can see various different models will use different types of tokens, right? And at the end of that, we count all of these up and we get a tokens for the number of messages. So we're taking in a list of messages. And then what we're doing is we put in a model. So you can see we've got GPT 3.5 Turbo 0301. And we've got a list of messages here. And what's going to happen is you'll see that we can get around about 127 prompt tokens created or counted for that. Now, we've got a example here where you're a helpful assistant for a financial news website and you're writing a series of articles about the 2008 financial crisis. You've been given a list of headings for each article and you need to write a short paragraph for each heading. And basically we're saying generate some really high quality content, and we give it all of the subheadings from those article headings that we described earlier. We set up our chat history Python list and we add the system message to the top one of those. So you've got the content here being the system prompt and the role being system. Now, just to simulate how you would do this in real time. So GPT-4 Turbo, for example, has got around 120,000 token context limit. You've got a 3.5 Turbo that's got around 16K context, which has been recently extended. So you're not really going to hit context window limits all the time, but just to simulate what would happen if we were to hit a context window, let's just say that the context window is 2048 tokens. Okay, so it's quite small. It's not too small though. What we could do is we could loop through all of our article headings and we can say chat history append, write a short paragraph about the heading from the role of the user. Then we're going to get our ChatGPT response to take in the messages and produce a response. And then we're going to take the response and append it in and pass for the chat history back in. So we're just getting the most recent message. And then once we've added that on, what we're then going to do is we're going to check in the chat history for the number of tokens in the chat history, given that the model is GPT 3.5 Turbo. And if it's greater than this number, what we're then going to do is find the oldest non-system message. So that'll be a user message. It'll be the oldest message. And then if there is one, we're going to pop it out of the chat history based on its index position. So we're finding the index position by using this enumerate, which gets us the index. And we're only getting the index for one that isn't a system message because we want to keep the system message. Now we've put a nice print statement here, says remove the message to reduce token count. And we've also got the response. To start with, we'll see that we're not really excluding any specific chat completions. So the chat completions are coming in, we keep passing the chat history using this pass for chat history function and adding on the most recent message, but we're not pruning any because the context window hasn't got larger than 2048 tokens. But at some point, we're probably gonna, after writing some content for a certain number of tokens, you can see now we are starting to remove messages. And this therefore allows us to keep our chat history Python list below a certain token count. This is a good example of if you need to keep below a certain token count, the most obvious thing to do is to just start removing the oldest messages, primarily the human messages or the AI messages. You probably want to keep the system message in there because it's probably used for instructions. But if you're, specifically removing older messages, they're probably less relevant to the queries that your users are currently interacting with at this point in time. Now, this isn't the only method that you could use to prune the chat history. Another way you could do this is, rather than finding the most recent messages that you don't want to have at the top, the oldest user or assistant message, you could also summarize the entire message history with another ChatGPT call. And after you've summarized it, then you could then delete that old chat history and start with a summarized version. And you would keep re-summarizing as you hit over 2048. We'll look at summarization methods when we look into the LangChain content. Cool. All right, hopefully you learned a bit, and I'll see you all in the next one.